Okay, let's look at the homework in 17.4. Let's look at number 4. I'm going from 0, 1 to 0, 0 to 1, 0 to the parabola. So I'm starting here, going to 0, 0, going to 1, 0, and then going to this upside down parabola. And that's positive orientation, so that's okay. That's my curve. And I'm going to use the theorem first, which says I'm going to integrate that over the region. Q, this is P, this is Q. Q with respect to X is 0. P with respect to Y is 0. Well, that's just 0. So that's using Green's theorem. If we do the actual line integral, then we have to get paths for all of these. So A is Y equals 0, X between 0 and 1. So we could say X is T, Y is 0, and integrate 0 to 1. T dt plus 0 dt. That's going to be t squared over 2, 1/2. So on the first curve, it's a half. For the second curve, I'm starting at 1, 0 and going to 0, 1 on the parabola. So I can't just pick t. I'm going to go backwards, so I'm going to pick x to be 1 minus t. And then y is the parabola 1 minus x squared, so that's going to be 1 minus t squared. Because this is from when t is 1 to 0. So when t is 0, you see that x is going to start at 1 and y is going to be 0. And then when t is 1, I get to the point 0, 1. So this works. Okay, so I substitute them back in. I'm going to get 0 to 1. X is 1 minus t dt. Dx is negative dt plus y times the derivative of that okay, that's plus times the derivative is minus dt. I already took that into consideration, so that's just dt. Okay, it's all dt, so I don't. Okay, integrating. All right, integrating this is minus 2t plus t squared times 2 minus 2t. So that's going to be minus 4t plus 2t squared plus 4t squared minus 2t cubed. That's 6t squared. And that's plus minus. I have my signs wrong. Okay, so that's 2t squared minus 3t squared plus t to the fourth over 2, 0 to 1. So that's going to be 2 Okay, that's 6t squared. When you integrate that, you get 2t cubed. So it's minus 2 plus a half. So 2 minus 2 is 0. I'm adding these two together, so half and half is 1 minus 1. That's just going to be 0 on that curve. And then C, it's x equals 0 for y between 0 and 1. So x is 0, y is 1 minus t because I'm coming down. I'm starting at 0, 1. Okay, so I'm integrating 0 to 1, 0 dt, plus 0 to 1, 1 minus t, minus dt, and that's minus t plus t squared over 2, 0 to 1 is minus 1 plus a half is minus a half. When I combine that with this a half, 0, and negative a half, I'm just adding up all the curves. The result is 0. When I add all those up, I get 0. So that's what I got. See how difficult it is to integrate along that curve? When I use Green's theorem up here, I got 0 right away. So they just want you to see that. Number 6, I'm going on the parabola and then I'm coming back down. And that's positive orientation. So on the first curve, x is t, y is t squared. Let's do this first. Let's substitute it in. I'm going to get t to the 4th sine t plus t squared sine t squared, and dy is 2t dt. And then on the second curve, I'm going to get 0 to 1. I'm going to let's let that be a, b. Since you're going backwards, let x be 1 minus t. X and y are the same because that's the line y equal x. B is the line y equal x. So I'll parameterize it this way. Oh, after I substitute it back in, that's not what I'm going to get. Okay, I'm going to get okay, in Maple, okay, again, what did I do? I substituted that back in because P is x y squared sine x. So I'm substituting A and B curves, the parametric curves into that. Substituting that in. Okay, I'm going to do this in Maple. Okay, command is int t to the 4 sine t. And then that other stuff is twice do the same thing, so I'm just going to combine them and say it's 1 minus t squared times the sine of 1 minus t. And then I'm going to go from t equals 0 to 1. So this should give me the result of the line integral. That's going to take a while to work out. Okay, I made a mistake somewhere. I didn't put my times in here. 2 times. Okay, now let's go back and work it with the double integral. With the double integral, I'm just taking the area of that region. So with the double integral, I'm integrating x squared to x from 0 to 1. Q of x minus p of y. So this is q of x minus p of y. Okay, let's do that in Maple. I'm going to do a double integral, so I'm just going to do them both at the same time. 2 times x times same answer. So that's what they wanted you to see there, that you'll get the same answer either way you do it. Okay, let's try number 8. Okay, the region is 0 to 1. And this is 1, 3. So this equation y equals 3x. So I'm just going to do it by getting the double integral. The area of that region is 0 to 3x, 0 to 1. Q with respect to x minus p with respect to y. Okay, integrate with respect to y first. Oh, I drew the picture wrong. Okay, let's go back. This is the region. I'm going from 3x to 3 is 0 to 1. So I'm going from 3x to 3 here, and then I'm cutting up 0 to 1. Okay, sorry about that. That's going to be 81 minus 9x squared minus 81x to the 4th plus 9x to the 4th. Okay, integrate that with respect to x. And we go from 0 to 1. Plug in 0, you get 0. And you can work this out. It's 318 over 5. Okay, let's try 14. Okay, our region looks like this. That's in the negative direction. So we're going to have to go the opposite way. And the integral f around c is going to be negative the integral around negative c. So that's going to add a negative. We're going to do it over the region. Qx is 2x plus 2y cosine x. Py is 2y cosine x. We'll go dy dx. Okay, so since we have to switch direction, we need that negative out in front. We're going to go from the line here is y equal 3x. So we're going from 0 to 3x, 0 to 1. The integral with respect to y is 2xy. Integrate that with respect to x, 2x cubed. Oh, I'm sorry, this point is 2, 6, so we're going from 0 to 2. And I need that negative out front. So our final answer is going to be minus 16. Okay, 18. That's in the positive direction around this semicircle. So around that region, I'm going to do Qx minus Py. Alright, that's going to be square root of 4 minus x squared, 0, negative 2 to 2. I'm going to change this to polar. So in polar, this is r equal 2. So I'm going to go from 0 to 2, 3r squared. This is r squared. With polar, you need another r there. And we're going to go from 0 to pi because our circle is the half, goes from 0 to pi. Okay, now we're going to integrate that with respect to r. That's 3r cubed, that's r fourth over 4, 0 to 2 is 12. And then we integrate 12 with respect to theta, that's 12 theta. And our final answer is 12 pi. Okay, so I hope this helps you with some of your homework problems.